Yeah, in the previous classes, we have seen about the linked list. Now we are going to see about the types of the linked list. Here we have the 4 different kinds of the linked list. We are going to see all those 4 now. That is a single linked list, double linked list, circular linked list, and the circular double linked list. In each and every linked list, we are going to see what are the various operations we have performed. First, we will discuss about the linked list. The similar definition, what we have studied till now, is a common to the single linked list. What does that means? Here, we are going to have the pointer, which is going to have the address of the first element. And this first element, every node, this element is also called as a node here. And in a node, we have the 2 parts. The first part is about the data, and the second part is about the address, and this address is going to point to the next element, next node where the actual value is stored here. And this element, this node is going to point the address of the next one, and this one is going to point to the address of the next one. This is called about the single linked list. Already we have seen all these definitions in the previous videos. Now let me say about what are the various operations we are going to perform on this linked list. That is insertion operation. Yeah, all this one are completed in our previous videos. Now we are going to see the insertion operation in a single linked list, and these insertion operations are done in the 3 ways. First is the insertion at the end, insertion at the end, at the front, at the end, and at the middle. We have the 3 different kinds of the insertion. Not only in a single linked list, whatever the linked list you take, these operations are common. Now we are going to see one by one. First, we need to create a node for a single linked list. In the previous class, we have seen that how to create a node. What is a node here? This is a node, and the node will have the 2 parts. First part is about the data, and the second one is about the next. If you observe this node must be the common for the complete linked list. So how you have to create that node as a global variable? Like in our C coding, you would have seen that int a, what will happen? 4 bytes will be allocated to that a variable. Now in the similar way, I need to allocate the memory for this particular node. So how the data type should be? If you observe this one here, we have the 2 different kinds of the data types. This data type will come under the integer part, and this one will come under the address part. These are the 2 different data types. When you are combining the 2 different data types, how you have to combine that one means by using the struct node. Struct data type. Struct is a keyword which will help you to combine the 2 different data types. Now if you observe that, already we have discussed that this is a node, and the first part is about the integer, and the second part is about the address. Here also, the first part is data, and the second part is next. And I need to implement this node in every function, like in the main program, in the insertion program, in the deletion program, it must be there. So what we have to do means we are going to declare this node as a global variable. Now we are looking at the discussion, global variable. What is the difference between the global variable and the local variable? If you declare any variable inside the main program or inside any particular function, that variable can be utilized there itself. From outside of the function, I cannot utilize that one. That is called as a local variable. Now, this one is not like that. I need to use this node in the main function, in the insertion function, in the deletion function, whatever the function you create. This is a common thing. So what I have done here means we are going to declare this struct node from here to here. This declaration is done as a global variable. Global variables, before you write the main program, you need to decide the variable declaration like this. These type of declarations are called as a global variable. Now, from the main program, what is our first thing here? I want to create a node. I want to create a node. And in the first part, before main program starts, what we have done? We have declared the variable struct node, and in that node, I have the 2 parts, that is the data part, and the next one is a pointer next. Struct node pointer next. A pointer will help you to store the address where the actual element is stored. But if you observe here, we are writing struct node, the same name. Whatever the name you have given there, the same name will be repeated. So that's why this is called as a self-referential pointer. Why? Because I am not giving the direct address where the element is stored. I am going to point to the address where the similar type of node is there. In that one, there is no data directly. What is there? It is the address of the another node. That's why this is called as a self-referential pointer. Done. So this is about the struct node, and we have declared this one before the main program starts. Now what is our task? I need to create a node. I need to create a node in the main program. In the main program, struct node pointer head. Now see, usually in the int main, if I say int a, what happens? 4 bytes will be allocated in the same way. Now what we are doing? I am taking the one more pointer, that is a struct node pointer head. So one pointer is going to be allocated, and the name of this pointer is head. Pointer is head, and initially it will be null. Till now, what we have seen in the linked list, we are going to have the head pointer which will point to the first which is going to point the first element of the linked list. Initially, how we have to take that one means struct node pointer head, and it will be having the null value. Now, how to allocate the memory? Now, I want to create a node. I want to create a node. Creating a node is nothing but allocating the memory. How we have to allocate the memory? If you observe this one, this is a just variable declaration, still the memory is not allocated. Now in the linked list, already we have seen the difference between the array and the linked list. Array is a static memory allocation, but when it comes to the linked list, it is a dynamic memory allocation. How the memory will be allocated to a node means, if you observe, node equal to struct node pointer. I need to say the prototype here. Struct node pointer. Malloc is a keyword. Memory allocation. Malloc is nothing but dynamic memory allocation. Whenever you are calling this function, memory will be allocated dynamically. After that, how much memory must be allocated? How much space is required by this node? That much amount of the memory must be required. So size of struct node. This line is very important in each and every function, in each and every program when it comes about the linked list. This line is very important. First of all, I need to allocate the memory. How I need to allocate the memory? If you say that struct node pointer, after that malloc. Within the malloc, I need to specify the size, how much size I want. But I cannot say that 40 bytes, 50 bytes or 60 bytes. Then how much? Which means that size of this struct node. Like this we need to represent in the form of the coding. After that, the memory is allocated randomly, we can say it as 1000. In that 1000 space, I got the node. The memory is allocated for this particular new node. Now the name for this one is new node. New node data equal to 20. And after that, new node next equal to null. So what we have done, this is a simple creating a node in a linked list. Now what I have to do, I need to insert this node in the form of the single linked list. Now how can I insert this one? Where I can insert this one means in 3 ways, that is insert at the front, insert at the end and insert at the middle at the specified position. Now we are going to see at the insert at the front. See here, pointer. If you observe this one, this is the first one, initial single linked list. If you observe this one, this is the starting pointer, head pointer, where it is having the address of the first element. If you observe here, 100. In the 100, I have the data and the next address element. Now, I want to insert an element at this particular position like this. So, what I have to do, in this start, I should replace this one with the address of the new node. And in this new node, I should have the address of the 100. I should have the address of the head like this. This is about the insertion at the front. Now we will see the algorithm. Now see how the memory must be allocated. Already we have decided that struct node pointer, new node. I need to allocate the memory for this new node, and in this one the prototype must be there, memory allocation, and how much size must be declared, should be declared like this. After this one, the new node is created. The new node is created with the 500, and in this one new node data equal to some value, and the new node next equal to head. Initially what is there, how much, 100. So I am going to write it as a 100, and after that start equal to 500, head equal to new node, which means that this is pointing to this one and this is pointing to this one. There is no allocation for this one. Now if you observe this one, this is the starting pointer which is pointing to the first node, and the first node is pointing to the next element of the node, and this is a algorithm. Let me explain again the same thing in a clear manner. First, look at the algorithm. What I have to do, this is a single linked list. In this single linked list, my task is I need to insert a node at the beginning. Here I want to insert, this place I need to insert, and already we have seen in the previous one how to create a node, and here I have inserted some value and the next value is equals to null. Now I need to insert a node at the first position, which means that this node must point to this one. But where is the address of this one? It is already there in the head. So that's why we are writing new node next equal to head. So here we are going to write the value 100. After that, this start pointer should not refer to this one. It should refer to the new node. That's why head equal to new node. You need to remember clearly that first get the address and store it in the new node. After that, you need to change this address, start address, with the new node address, that is the 900. This is about the algorithm of the inserting at the beginning. Now we will see the coding for this void insert at the beginning. We will just look at line by line and function by function. Now in the program, we will see insert at the beginning, and we will display that values, and we will see how we are going to call that insert at the begin function and display function. Whatever we have discussed in the linked list and how we are going to insert an element at the beginning, the same thing we are going to see in the program here. So in the main program, first we need to declare the header files. What are those header files means? Definitely we need to include the 3 header files. One is the standard input output.h. The other one is standard library.h, which means that where we are going used to like anything printf, scanf statements, such type of things will be included if we use a hash include standard library.h. Now the one more thing we need here is conio.h. Why? Because usually we go with the void main and get.ch. When you are using the get.ch, definitely you need to include the conio.h header file. Now, already in the class we have discussed that how to create a node, and that node declaration must be done as a global variable. And how to do that one means we have seen in the class struct node. And in this node, I need to declare the 2 parts. The first part is int data, which is of the integer data type. The other one is the address. It is a pointer. So struct node pointer, we are giving the same address of the node, which means a similar element of the address. That's why we are going to point this particular line as a self-referential pointer. And you need to remember very clearly that we need to close this one by using the semicolon. Yes, this is a global declaration of a node. After that, I want to perform the insertion function. When you want to perform the insertion function, before you write the main program, first define that program. How you need to write the definition for that program. So I'm going to write void. Now my function name, I'm going to declare it as insert at begin. Yes. Now for this one, I'm going to take the value int data. Why? Because I'm going to get the data from the main program. If you are inserting a value is nothing but I need to insert some values, right? So I'm going to get that data from the main program. That's why here we are declaring int data. Now I need to declare the struct node pointer head. Struct node pointer head equal to, initially it will be null, and the null should be of the capital letter. Struct node pointer head null. Now what I have to do? I need to check if head equal to null, I can place it, or else directly I can write that. Wait. Instead of declaring it here, I'll make it as a global one. Why? Because I can change it anywhere. So I'm going to type it struct node pointer head equal to null. And here I'm going to get the value. I'm going to insert in the insert at the begin function. Int main program. And from this main program, I need to call that function. So in the main program, first let me write int data printf, enter the data, scanf, %rd, comma, ampersand. Whenever you are using scanf, you should not forget that you should use the ampersand symbol there. Yes, done. Now I need to call that function insert at begin function by sending this value as a argument. So no need to declare the int data type. Why? Because already we have declared this int data. So I need not declare it here, the prototype. So directly I can write the data. So the cursor will move from here to here. Done. Now already we have said that head equal to null, which means that the starting pointer is null. In insert at the begin function, already we have seen that the head pointer is going to point to that new node. So insert at the begin. First, I need to allocate the memory. I need to create a new node. Already we have seen the definition how to create a new node, that is struct node pointer, and you can assign any name. Now I'm going to say it as a new node. Now, the first one I should declare the prototype, that is a struct node pointer, and malloc is a keyword which will help you to allocate the memory dynamically. And how much memory must be allocated? Size of, how much size? That is a struct node size. So directly I can write like this. This line is very important, and this is a common line in all the functions. Now the memory is allocated. Now in that memory, what I have to do? New node data. Already we have discussed that new node will have the two parts. That is the data part and the next part. New node data part is going to have that data. Whatever the argument you have specified here, whatever the argument you are getting from the main program, I'm going to send that data into the new node data. Yes, and new node next equal to how much it should be? It will be same as that of the head. Why? Because whatever the address is there in the head, I'm going to store it in the new node. And after that, I'm going to change the head address with the new node. This is what we have seen in the code, in the explanation also. The same thing I have returned here. Is that clear now? See, this is a global declaration from here to here. This is a global declaration of a node. And here I have declared one more variable as a global declaration, that is a head. And initially the head value will be equal to null. And after that, before you call from the main program, I need to define the program. What is that function name here? Insert at the begin function. I need to define that function, and this is the function. And in this function, what we have done, whatever the value of getting from the main program, I'm going to pass it into this function. And in this function, the first line indicates that the memory is allocated. The memory is allocated, the element is created, the node is created. And in this node, I have the two parts. The first part is about the data. And in that data, I'm sending whatever the value got from the main is sent it to the new node data. And after that, the head value. If it is the first element, means in the first element already it is null. So it will be marked as a null. After that, we are going to change the address. Every time it is going to change the address. New node next equal to head. Head equal to new node. This is the algorithm. Now, this will be working clearly, but how can I know that this is working clearly until I print the values? So again, I'm going to write the function void display function. Why? Because I need to print the values. Then only I can say that the program is executed successfully. So again, I'm adding void display function. In this display function, I'm going to take extra pointer, that is a struct node pointer temp equal to head. And what I will do means until I get the value null, I'm going to add it while temp not equals to null. Null should be every time capital. While temp not equals to null, what I have to do? I need to print the data, that is printf percentile d comma, let me add one more, this one, yeah, comma, the data will be in the temp data mode. And after that, I should move towards the next set, temp equal to temp next. Done. That's it. Now the display function is completed. Now I need to call this function also in the from the main program. So let me edit a few more things here. Let it should ask me to enter my choice whether I want to enter the data or I want to print the display the data. So let me write it here. If I press the 1, it should ask me to enter to insert the data. To insert data. Now the second one is if I want to display, I need to press the choice 2. So I'm writing it like this. So if it displays like that, then I can choose my options. So in order to display like that, I'm writing here display program. Yeah. Now it should ask me for the choice. Enter choice. Enter your choice. Now let me add the scanner statement to read my choice. Scan of percentile d, comma, ampersand of choice. And let me add a slash n so that it will be very clear. Let me enter my choice. Yes. Now according to my choice, I'm going to call the function switch. The switch statement is used to execute only one particular operation. Now if I want to perform only insertion, only that task must be done. And if I call the display, only that function must be executed. Means either or, only one function must be executed. In that case, we are going to use a switch statement. And the case is a keyword which will help you to get into that particular one. In the case one, I'm calling the insert at the begin function. And after this case one, I'm going to use the keyword break. The next one, case two, is about I want to display. So directly I'm going to call the function display function. And for this one, I don't require any parameters and I'm going to add break statement. Why the break must be there means in order to skip the next one. If you are not writing that break means it will enter even the next case also by default. Case 0 to return. Now if I press the 0, it will come back to the main program. If I press 1, it will ask me to enter the data and the particular insertion function will be called. If I call the 2, then the values will be displayed. In this how we have returned the main program. Now let me conclude this one by just displaying the output. Let me save the program. Yes. Done. And here the spelling mistake struct. Yeah, the global declaration is not there. So declare the variable here. Function should have the return value. Done. Enter the choice. Press 1. Enter the data 23. Now again I want to choose the same thing 1. But it is not entered into the same part. How it should be done? It should ask again and again. So what I will do here means I'll enter into the infinity loop, that is a while. Until you press the 0, we'll be in the same loop. So press while 1. You need to save the program before you compile it. Integer twice 1, 23. Now again I press, again I want to insert a value. Again choose option 1, enter the data 45. Again I want to choose the option insert only. Press 1 and enter the data 87. Now let me choose the option to display. Now we can see that the last element is printed first. 87, 45, 23. In this way, we can perform the inserting a node at the beginning function. Now let me exit this one by pressing the choice 0. Thank you.